Welcome to WE Math class. Today we will introduce a new topic, Fourier series. In many scientific problems, especially in the study of periodic phenomenon in conduction of heat, optic, electrodynamics, it is necessary to expand a function fx in a trigonometric series of sine and cosine in a form a series known as Fourier series. Some important definition to know about Fourier series. We first know that what is periodic function. A function if from real number to real number R to R is said to be periodic if there exists a positive number capital T such that f of x plus capital T is equal to f of x. This capital T is called the period of the function. And we also know that J sin x cos x are periodic function with period 2 pi, and cot x tan x are periodic function with period pi. You also know even function and odd function. A function f of x is said to be even function if a function f of x is said to be even function if f of x is equal to f of minus x is equal to f of x. Let f of x is equal to x square plus 4. This is an even function as f of minus x is equal to minus fx the square plus 4 is equal to x square plus 4 equal to f of x. As f of minus x is equal to f of x, therefore it is an even function. A function f of x is called odd function if f of minus x is equal to minus of fx. Like that, f of x is equal to x cube plus x. This is an odd function as f of minus x is equal to minus of x the cube minus x. If we put x is equal to minus of x minus x cube plus minus x minus common x cube plus x minus of f of x. As f of minus x is equal to minus of f of x, therefore the function f of x is odd function. Sin x is an odd function, whereas mod of sin x is an even function. We also know some result integration minus L to L fx dx is equal to 0 when f of x is an odd function. Odd function. Integration minus L to L f of x is equal to 2 into integration 0 to L fx dx when f of x is even function. Also known some result if n is an integer, n belongs to z, n is an integer, then cos of n pi equal to minus 1 whole to the power n. As cos of pi equal to minus 1, cos of n pi minus 1 whole to the power n. Sin of n pi is equal to 0. as sin pi 0 sin n pi 0. Cos of 2n plus 1 pi by 2 is equal to 0, as cos pi by 2 0, so multiple of pi by 2 0, and sin 2n plus 1 pi by 2 equal to minus 1 all to the power n. Now we know what is Euler's formula for Fourier series expansion of a function f of x. Let f of x be a periodic function with period 2 pi. Suppose f of x can be represented as a trigonometric series in the interval c less than x less than c plus 2 pi as follows: f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to 1 to infinity bn sin of nx. Then a0 equal to 1 by pi integration c to c plus 2 pi f of x dx. This is a0. an is equal to 1 by pi integration c to c plus 2 pi fx cos of nx dx n equal to 1 2 3 dot dot, and bn is equal to 1 by pi integration c to c plus 2 pi fx sin of nx dx n equal to 1 2 3 dot dot. Some special case, in particular case 1, if c is equal to 0, then the interval reduces to 0 less than x less than 2 pi. If c is equal to minus pi, first we minus pi, then 0. If c is equal to minus pi, then the range change to minus pi less than x less than minus pi plus 2 pi, minus pi less than x less than pi. If c is equal to minus pi, then the interval becomes minus pi to pi. And then the above series is given by fx is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx plus summation n equal to 1 to infinity bn sin of nx. Then a0 equal to 1 by pi integration, this range is changed minus pi to pi, minus pi to pi fx dx. an is equal to 1 by pi integration minus pi to pi minus pi to pi fx cos of nx dx n equal to 1 2 dot dot, and bn is equal to 1 by pi integration minus pi to pi fx sine of nx dx n equal to 1 2 3 dot dot. If special form 1, if f of x is an odd function, what happen? Minus pi to pi fx dx is equal to 0. Therefore, if f of x is an odd function, then we know that minus pi to minus l to l fx dx is equal to 0. Therefore, a0 equal to 0. We a0 is equal to, we get a0 equal to 0. And f of x is an odd function, and cos of nx is an even function. Cos x even function, f of x odd function. Their product is an odd function. Therefore, an 1 by pi minus pi to pi fx dx is equal to 0. Therefore, an is equal to 0. And bn, as f of x is an odd function, sin x is an odd function, therefore fx into sin x, this is even function. Therefore, bn is given by bn is equal to 1 by pi integration 0 to pi 2 into 0 to pi fx sin x dx. Let f of x define in minus pi pi be a periodic function with period 2 pi. Now, if f of x is an odd function, then its Fourier series contain only sine term. Thus, we have fx is equal to summation n equal to 1 to infinity bn sin nx, where bn is equal to 2 by pi integration 0 to pi fx into sin x dx n equal to 1 2 3 dot dot. Special form 2, if fx is an even function, then a0 is equal to 1 by pi integration minus pi to pi fx dx is equal to 2 by pi integration 0 to pi fx dx. As fx is an even function, Therefore a0 or a0 is equal to 1 by pi minus pi to pi fx dx. Therefore if fx is an even function, then a0 is equal to 0 to pi 2 by pi fx dx. যেহেতু as fx is even function and cos of nx is an even function, therefore their product is an even function. Therefore an is equal to 2 by pi 0 to pi fx cos of nx dx. For bn, an is equal to 1 by pi integration minus pi to pi fx cos of nx dx. As fx is even function, cos x is an even function, their product is an even function. Therefore 1 by pi 2 by pi 0 to pi fx cos of nx dx. And bn is equal to 1 by pi integration minus pi to pi fx sin of nx dx. As fx is an even function and sin x is an odd function, their product is an odd function. Therefore 1 by pi minus pi to pi fx dx, this is equal to 0. Let f of x define in minus pi comma pi be a periodic function with period 2 pi. Now if f of x is an even function, its Fourier series is given by f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos of nx, where a0 is equal to 2 by pi integration 0 to pi, a0 is equal to 2 by pi integration 0 to pi fx dx, and an is equal to 2 by pi 0 to 0 to pi fx cos of nx dx. As sin of bn is equal to 1 by pi eta minus pi to pi fx sin x dx is equal to 0, therefore even function we get only cosine term in the Fourier series expansion, and if odd function then we get only sine function in Fourier series expansion.